Okay, today's lesson is lesson 3-7, parallel lines and transversals. First of all, guys, I know this is very low resolution. For some reason, my PDFs were not translating very well, but we'll work with it. But this starts on page 207 of your textbook, okay? So today's goals is what we'll first look at. We need to identify special angle pairs, parallel and skew lines, and transversals, and then also find values by applying theorems about parallel lines and transversals. So first of all, before we get into the lesson, we need to review some vocab. That first term should be somewhat familiar, parallel lines, okay? So the formal definition states they are parallel lines, they are coplanar lines that do not intersect. That's the kicker. So lines that never ever intersect each other will be parallel. If you think back to algebra, if you remember parallel lines, they have a special property with their slopes. Both lines will have the same slope, okay? And that's what causes those lines to never ever intersect. In that example, it says JK, and then they have two vertical lines there. That symbol right there, that means parallel. So off to the side there, if you want to make a note, if you have two vertical lines, that means parallel. And then thinking back to previous lessons, another symbol that we used was the upside down T. That means perpendicular. So that's the difference between those two symbols there, okay? Some new words that we're going to look into. First of all, we have skew lines. Skew lines are lines that do not intersect and are not coplanar. And if we look here at the example, we have a plane here. That would be considered plane A. And then we have a separate plane B right underneath it. And so those lines are on those two separate planes, and because of that, they will never intersect naturally just because they're on separate planes. And they're also not coplanar, so that would be skew. Parallel planes are just planes that do not intersect. Okay, so it's similar to the parallel line definition, but now applied to planes. Okay. So let's look at example 1. Here we are practicing identifying parallel and skew relationships. So that first question says, identify all lines that are skew to line BC. And so line BC is found, let's use red, right here. And it's found on that top plane. So if I were to continue to outline that top, line BC is included there. So that's the plane that line BC lies on. BC could also lie on that further back plane. I'll outline in green. So that further, furthest side, BC is also included in that one. But we're focusing on the line, and we're trying to figure out another line that would be considered skew. Okay, so if we go back to our definition of skew lines do not intersect and are not coplanar. So as long as I think of an example where the line is not on the same plane as that line BC, it's going to work. And so they've given us examples here. They said AF is not on the same plane as BC. Well, that's true. There's not a side, that those two lines connect and create together. So there's not a plane that they're on together. Same thing with DE and FG. Okay. And so that fourth example would be HE. That line there would be considered skew to BC. My next question says, identify all lines that are parallel to EH. Okay, so if I look at EH, They've already given us some examples of parallel lines. They said AB, which is true. They will never intersect. CD, that is also true. And then that third line that's going to be parallel is going to be its opposite side on that bottom plane, also known as GF. Then that next question says, identify all planes that are parallel to plane DCH. So DCH is going to be this plane right here. So we're identifying parallel planes. What's a plane that does not intersect this one here? Well, the only option would be the plane directly across to the left, aka plane ABG, right here. And so over to the right here, at the talk about it portion, they pose a very good question. It says, can a two-dimensional figure contain skew lines? Justify your argument. So let's think about that, okay? Think about a two-dimensional figure that you use almost every day in your lives, especially with you being in school, okay? Hopefully a piece of paper came to mind. So if I have one piece of paper, if I draw any lines whatsoever on that paper, eventually, by definition of lines going on infinitely in both directions, those lines will intersect. So because of that, if you have a two-dimensional figure, it will never contain skew lines. Skew lines will have to be created on those three-dimensional figures because those have multiple different planes. And so that's what we saw here with that cube. Okay, that cube had multiple planes, so that's why there were multiple skew lines. But on a two-dimensional figure, no. Okay, you cannot have skew lines. All right, we're going to go on to the next page, on page 209 here. Okay, we are going to look at the learn portion where it says learn angles and parallel lines. So what we're focusing on today is when I have two parallel lines and I have a line that cuts through them, first of all, the line that cuts through those two parallel lines has a special name. We call that a transversal. And that's all it means. It just means a separate line that is cutting through those two parallel lines. So when I have a transversal cutting through a set of parallel lines there, special angle properties are formed. And so that's what we're going to look at next, all those different angles and their names, and then also those properties. So the first type of angles that are formed whenever I have my parallel lines that are cut by the transversal, we have corresponding angles. And so they've given us a list of examples here. Okay, so look at those examples and try to think of a description as to what those angles relationship might be. So the first example is angle 1 and angle 3. And then the next is angle 2 and angle 4. So hopefully as you go down the line, you kind of notice that each of the angles are equal measure, or they look equal, okay? If I look at angle 1, that looks very obtuse to me. If I look at angle 3, that looks obtuse as well, okay? If I look at, let's talk about this last example, angle 8 and angle 6. So angle 8 looks acute, angle 6 looks acute. So each of these pairs are the same to the angle it's paired up with. So for that reason, corresponding angles, their special property is that they will be equal measure. Okay. Let's look at our next type of angle. We have alternate interior angles. And again, they've given us some examples here. So the first example they gave was angle 2 and angle 6. So alternate interior And then another type we'll talk about later, alternate exterior. The name says it all. It tells you exactly where they're found. So alternate meaning, switching. Interior meaning inside the parallel lines. So any angles here, guys, that are found inside those parallel lines, those would be considered interior angles. And notice how angle 2 and angle 6, they're kind of on opposing sides of that transversal. So they're swapping, okay? And let's also look here. Angle 2 is an acute angle. Angle 6 is an acute angle. So they're the same. And so that special property there will also be that they are equal measure. Okay. My next type of angles are consecutive interior angles. So again, oopsie. Okay. So when I see the word interior, I know that they are found in that red portion there. So anything inside the parallel lines. And then consecutive just means that they are found on the same side. So the first example they give is angle 2 and angle 3. So angle 2 and angle 3, notice now they're both on the same side. So they're on top of that transversal. And they're also inside the parallel lines. So that's the meaning behind the name. But angle 2 we said was acute. Angle 3 to me looks obtuse. So for that reasoning, they cannot be equal, but they're actually going to be supplementary. And hopefully you remember, supplementary means when you add those values together, they are going to equal 180 degrees. Okay. And then finally, our last type of angle, alternate exterior angles. So instead of interior, now we're working with exterior. Exterior means outside. So any angle that I have highlighted in green would be considered an exterior angle. And then adding that word alternate, making sure that we're kind of swapping sides. We're going back and forth. So if I look here, the first example they gave was angle 1 and angle 5. Notice angle 1 is on top of that transversal, angle 5 is on the bottom, so they're alternating, but they're both found outside the parallel lines. So again, looking at angle 1 and angle 1 is obtuse, angle 5 is also obtuse. The next example says angle 4 and 8. Angle 4 is acute. Angle 8 is acute. So if I ever have a pair of alternate exterior angles, I should know that they are equal measure. Okay, so over to the side, guys, somewhere in your textbook, please include these notes. A simple trick for figuring out angles with those parallel lines cut by a transversal. So first of all, if you have both angles that are the same, so let's say you have an acute angle and another acute angle. I may not really know their measure, but if they're both acute, then I know for a fact they're going to be equal measure. Same thing with my obtuse angles. I may not know exactly what they are, but because they are both obtuse, I know that they should be equal. Okay, and we're going to see in some next questions how that can be useful in solving for variables, but just keep that in mind. And then on the other hand, if you have one of each, so if you have an acute angle and an obtuse angle, well, they're both not exactly the same, but they're going to be supplementary. Okay, so if I add them together, they should equal 180. Okay, so if you would like to add this example, feel free, but I really wanted to show you guys exactly what I was meaning by the trick over here that I was talking about. So let's say you are given this set of parallel lines, okay? Another side note, if you ever have lines with triangle symbols like this, that also means that they're parallel. So just a heads up in geometry, that's another symbol that you might have to remember, okay? But anyways, so if I have two parallel lines, and these two lines are cut by that transversal, then the special angle properties will apply. And let's say I want to figure out what angle A, B, C, D, E, F, and G, I want to know what their actual measure is. So I have one measure here. I know this angle is 80 degrees, okay? So if I use my trick for the parallel lines, I know that all my acute angles are going to be the same and all my obtuse angles are going to be the same. If I look here, 80 degrees is an acute angle. So what I'm going to do, I'm going to go down the line here and find all my other acute angles, and those should also be 80 using that trick that I just showed you, okay? So that's 80 degrees. If I see here, angle B is also an acute angle, so that is 80 degrees. Angle C is another acute angle, so that should be 80 degrees. And so is angle F. That's another acute angle, so that is 80 degrees as well, okay? And so now I have to figure out the obtuse angles. What I might do is look at this top line here, and notice I said line, right? Okay. So starting back with the original 80, that 80 degrees in angle A, notice what they form here. We learned about that previously, okay? They form a line, and so together their sum should be 180. So if I want to figure out angle A, I'm going to take away what I know from the total. So my total is 180. I know one part of that line is 80 degrees. And so the other part should be 100. So that's what angle A's measure is, okay? Also, if you notice, 100 degrees is an obtuse angle. So that means, again, all my other obtuse options should be 100 degrees as well. So angle C is obtuse, so that should be 100. Angle D is obtuse, so that should be 100. Angle G is also obtuse, so that should be 100. So really, in a nutshell, guys, if you have these really simple parallel problems, you should only have one of two answers, either an acute angle answer or an obtuse angle answer, okay? Because like you see here in my example, the only options were either 100 degrees or 80 degrees, depending on what type of angle we were looking at. Okay, so I've given you another example if you wanted to add this to your notes. Go ahead and pause the video and just see if you can find all the values for all the different angles. Okay, so this is what you should have ended up with. So the angle that we were given was angle of 30 degrees, and 30 degrees is an acute angle. It's less than 90. So I know all my other smaller angles, my acute angles, should also be that 30. And so those angles being that measure should have been C, D, and G. And then to figure out the obtuse angle, I took my acute angle away from 180 and I got 150. So I showed that work here for angle B. And angle B is obtuse. Angle A is also obtuse. So is E and F. So for that reason, those should all be 150 as well. So hopefully these examples kind of made it a little bit more clear on how to use that trick that I told you previously. Okay, let's look at example 4. So I'm not too worried about the proof that they have here, guys. I really want you guys to focus on, can you figure out those angle measures, okay? And so in your textbook, you have a much clearer picture, but they want us to find the measure of angle 7. Now, if I look at angle 7 right here, I'm actually let's draw this out a little better. So angle 7 is found here. They've told us that angle 1 right here, angle 1 is 42 degrees, and we're trying to figure out angle 7. So if I look at angle 1, That is very obviously an acute angle. Angle 7 is also acute. So if I have two of the same type of angle, I've got two acute angles, that must mean that their measure should be exactly the same. So I don't even have to do any math for that reason. Since angle 1 is 42 degrees, angle 7 should also be 42 degrees. So same thing on the check, guys. Let's look at what type of angles we have. So it's told us that angle 3 is 62. Angle 3 is found here. 62 degrees is an acute angle. It's less than 90. Let's look at angle 4. Okay. Angle 4 is also an acute angle. So I've got two acute angles. That must mean their measures should be exactly the same. So the measure of angle 4 should be 62 degrees as well. Okay, so sometimes in your textbook, they kind of give a little bit too much information, but they have worked out the problem already for you in your textbook. But I'm going to go ahead and work it out anyways, and kind of talk through it. So please add any additional notes that you might need. But let's look at example 5. So example 5A, they've given us a bunch of information. They want us to find x, okay? They've told us that angle 3 is equal to 4x plus 7, and angle 6 is equal to 5x minus 13. So I'm looking at 3 and 6. Now, you could go back to your list of, the different types of angles and figure out what type they are, and then figure out those angle special properties. Or you could think to yourself, okay, what type of angles do I have? Do I have acutes or obtuses? And use that trick that I showed you, okay? So angle 3 and angle 6, those are considered alternate interior angles. And alternate interior angles are always going to be equal. Now, another reason, if I look at angle 3, that looks like an obtuse angle. Angle 6 also looks like an obtuse angle. So because they're both obtuse, they should be equal measure, okay? So obtuse should be equal to the other obtuse. And for that reason, I'm going to set the expressions equal to solve. And so if I want to get x by itself, let's maybe take away 4x. Then I'm left with 7 equals x minus 13. If I add 13 to both sides, x is going to equal 20. Okay, let's look at the next problem here. So here we're trying to find y. And they've given us that angle B is 68, angle 8 is 68. Angle 8 is found here. And angle 3 is 3y minus 2. Okay, so before we said that angle 3 was an obtuse angle. Angle 8, however, that is acute. And we actually know that for a fact because 68 degrees is less than 90. So I have one of each. I have an acute angle and an obtuse angle. And so for that reason, remember, when I have one of each, they're going to be supplementary. So then I can replace the expressions that they've given us into this equation. So angle B is 68. The other angle is 3y minus 2. And that is all equal to 180. I can combine like terms. So 68 and a negative 2, that's going to be 66 plus 3y equals 180. If I take away 66 from both sides, that's going to be 3y is equal to 114, I believe. Yes. And then divide by 3 on both sides. So y should be 38.